Today we are going to introduce a very special image generation model. It is called HiDream-O1. Just how special is it? Well, previously when we did image generation in ComfyUI, we would usually see three components for a model: the main model, the text encoder, and the VAE. But HiDream-O1 is not like that. It has no external VAE, nor does it have an independent text encoder. More accurately, it is a pixel-level unified transformer. It directly processes images, text, and reference conditions all within the same model. This leads to a very interesting result. When you first look at its workflow, you might find it a bit counterintuitive. It clearly looks like there is a clip and a VA in there, but in reality, they are just placeholders meant to be compatible with ComfyUI's existing node structure. The real core doing all the work is just the HiDream-O1 model itself. In today's video, we are not just simply showing you a new model. We are going to focus on solving one main problem: how exactly should we use HiDream-O1 in ComfyUI? Many people have various ways of using it, but I found that they all have some drawbacks. So I found a slightly unconventional method to show you guys. Let's first take a look at the generation effects of this model. Right now, you are seeing the text-to-image results. The details in these images, especially the ad text, product packaging, the depth between the character and the background, as well as the complex composition and text rendering. I think the performance is absolutely fantastic. Moreover, it also supports image editing and reference generation. Let's focus on the reference generation. Here, I gave it two reference images. It not only retains the key information of the characters and objects, but also reorganizes them into a new scene. What is even more interesting is that at the end, I will show you a special way to play with reference generation. This method was also mentioned in the official paper. It uses position maps of different colors to control where multiple reference faces appear in the final image. That is to say, the reference images don't just provide identity information. They can also correspond directly to the layout. This is seriously mind-blowing. HiDream-O1 is an open-source image generation model released by the official HiDream team in May 2026. The official positioning is very clear. It is not merely a text-to-image model, but a unified image generation foundation model. It can do text-to-image editing and personalized generation based on multiple reference images. Its parameter size is 8 billion. The official native repository provides two versions. One we call the standard full version, and the other is the dev distilled version. So, what is the difference between these two versions? The most direct difference lies in the sampling steps and how they are used. For the standard full version, the official recommendation is 50 sampling steps. For the dev version, the recommendation is 28 steps. Sounds like the dev version is much better, right? Fewer steps, faster speed, easy to run. However, it is a distilled model after all. In many scenarios, its response is more direct, but the details and textures sometimes can't match what we call the full version. On the other hand, the problem with the standard full version is also obvious. It is incredibly slow. Additionally, we need to pay attention to the resolution. HiDream-O1 does not support just any arbitrary resolution. Why? Because it deals directly with pixels, so we can't be too random with it. The official team emphasizes that it can reach 2048 by 2048, which is the 4 million pixel level. However, due to its positional encoding and model structures characteristics, it is best if we use some preset resolutions. The versions in ComfyUI are actually repackaged by the official ComfyUI team. Please note they need to be placed in the checkpoints folder, not the diffusion models folder, because it has to disguise itself as a model with three components. As for the formats inside, there is BF16, which you can consider as the original version. Then there is FP8 scaled, which you can consider as a quantized version. Also, both the dev version and the standard full version have these corresponding formats. There is also another format in here called MXFP8. What is this exactly? Well, if you are using some of the newer 50 series graphics cards, using this model format will give you much faster speeds. Roughly a 30% speed boost. To make the demonstration easier, I have also built the workflow on Running Hub. In the ComfyUI space, Running Hub is a fantastic online platform because whenever new models and extensions drop, they always follow up immediately. Plus, Running Hub provides an online communication platform for ComfyUI creators. where you can find tons of creative inspiration and practical workflows. Now, let's first take a look at the original test workflow provided by KJ. This workflow actually contains two setups. The top one is the workflow for the dev distilled model, and the bottom one is for the standard full model. Pay attention here, there is a comment that points out something very crucial. It says that the clip and VA are not truly independent models. They are just there so that the existing nodes can properly connect to the placeholders. This sentence perfectly explains why the HiDream-O1 workflow looks a bit weird. Let's look at the dev version first. It loads the HiDream-O1 image dev FP8 scaled model. Because it is a distilled version, the sampling steps are lower. Here we use 28 steps. The sampler used is LCM, and the scheduler is normal. The CFG is generally set to 1. That is just how the distilled version works. Since it is built for speed, the CFG is usually kept at 1. In addition, there is a node here called Model Noise Scale. We generally set this to 7.5, though setting it to 8 is also fine. There's also another node called HiDream-O1 reference images. This, of course, is for connecting the reference image. This means our prompt is encoded first, turned into conditions, and then enters the sampling process together with our reference images. The advantages of the dev version are very obvious. It is fast. If you want to test prompts, check out compositions, or see if the reference images can be understood by the model, using the dev version is absolutely fine. But its flaws are also obvious. Take a look at this generated result. The overall texture feels a bit weird. For example, in some areas the details are too soft, and the premium feel of the image isn't stable enough. Now let's look at the standard full version. For the standard version, we are still loading an FP8 model. For the sampling steps, we can use 40 or 50 steps, and the CFG can be set around 5. Here, an additional node is used called HiDream-O1 Patch Seam Smoothing. What problem does it mainly solve? As we all know, when generating large resolution images like this, a mode called tile is used. During tiling, seams can appear in the middle. This node is specifically designed to fix that seam issue. You just need to know that this node is a smoothing patch used when generating with the standard high-resolution model. The quality generated by the standard full version is noticeably more stable. The image details, character textures, and object structures are all much more confident than the dev version. But the biggest problem is still the speed. If we use 50 sampling steps for every image, especially for high resolutions like 2048 by 2048, the waiting time is extremely slow. So here is the question. If we want to generate images, do we only have to choose between the two? Must we use either the dev version or the stable version? I always felt there should be another option. After doing a lot of experimenting, I'm going to introduce a more unconventional workflow, but I think the results are much better. Let me start with the model selection. We won't use the dev version model. We will use the standard full version model. However, we also won't use 50 sampling steps. We will just use 28 sampling steps. For the sampler, I use Euler, and for the scheduler, we use normal. Since I am not using the distilled model, the CFG is set between 4 and 5. I have put together a comparison workflow for you guys. I need to emphasize here, you must include that smoothing patch node. Otherwise, you will clearly see blocky seams in those areas. Let's look at this comparison workflow. The model used here is the same. It is the FP8 version of the full model. The reference images and prompts are also basically identical. The only change is the sampling settings. Group 1 uses 50 sampling steps, which gives us an effect close to the original. Group 2 uses 28 sampling steps, but here we use a sampler from the DPM-BY family. Group 3 also uses 28 sampling steps, but the sampler I use is Euler. Keep in mind, the model hasn't changed, and we are not using the dev version. Looking at the results, you will notice that the quality generated by the 28-step Euler sampler has not noticeably dropped. It retains the overall texture of the standard model. At the same time, the generation speed is much faster than the 50-step setup, especially in reference generation. The retention of characters and objects is much more stable than the dev version. This is exactly what I think is the most valuable part of this workflow. It might not yield the theoretical maximum quality, but it is the most acceptable solution in practical applications. You can think of it this way. The dev version is great for quick trial and error. The standard version is for your final render. And the 28-step Euler setup is a fantastic compromise for daily use. It offers higher quality than the dev version and saves much more time than the standard setup. What we just talked about was mainly reference generation, but what if you want to do text to image? It is actually very simple. You just need to bypass the HiDream-O1 reference images node. That means your positive and negative conditions shouldn't pass through this reference image node. Just route them directly into the sampling process. Keep the rest of the setup unchanged. The model is still the standard version. The steps are still 28, and the sampler and scheduler remain the same. Here, I've created a text-to-image workflow. I set the resolution to 1728 by 2304. This size is quite suitable for generating vertical posters and character portraits. The prompt is for a gaming energy drink ad poster. It includes a character, a product can add text, button icons, and a rather complex neon gaming room background. This kind of prompt is highly demanding for the model because it isn't just generating a pretty character, it also has to handle product packaging, text typography, and the structure of a commercial poster. Look at the generated result. I think this is absolutely fantastic. The most notable thing isn't the character itself, but the completeness of the entire ad layout. The product can, the main headline, the selling point copy, and the bottom icon area all show a clear sense of layout. Even though you can't expect all the text to be 100% accurate compared to many traditional open source models, its understanding of long texts and complex design tasks is undeniably much stronger. So, if you are making product posters, social media ad graphics, game promo art, or packaging display images, I believe this model's advantages are very obvious. Next, let's test the reference generation. When we were exploring the workflow earlier, we were already using reference generation. Overall, my feeling is that HiDream-O1's reference generation yields even more pleasant surprises than its pure text generation. Especially when you give it one or two reference images, it can blend the character's identity, the object's features, and the scene style together very naturally. Of course, it is not without issues. When the number of reference images increases, the overall consistency of the image will drop. Try to keep it under 3 references for more stable results. Also, in the prompt, you must tell the model what each reference image is for. Don't write it too vaguely. Finally, let's look at that special reference generation. This inspiration first appeared in the HiDream-O1 technical report, and there are similar posts on X. The concept is super interesting. We use colored blocks like red, green, and blue to mark where different facial reference images should appear. Then, based on the correspondence between these colors and the reference images, the model directly generates these 3 people into the specified areas. In other words, it doesn't just look at what the reference image looks like, it also understands who should appear where in the frame. Here, since we are using reference images, we need to use the HiDream-O1 reference images node. Then in the prompt, we describe a scene with multiple people interacting or chatting. In the final generated result, the correspondence between character identities and their positions is maintained to a quite usable degree. But you must note, this trick is not 100% stable yet. However, the direction itself is highly valuable because in the past, when we generated multiple characters, the biggest headaches were face swapping, chaotic positioning, and incorrect character counts. HiDream-O1's multi-reference plus layout guidance gives us an entirely new processing method and solution. Of course, we must mention the limitations here too. First, the more reference images you have, the messier the image tends to get. Second, the more subjects there are, the harder it is to guarantee consistency. If you also demand that it generate a large amount of accurate text, the difficulty will increase even further. Finally, let's summarize. HiDream-O1 is an image generation model well worth your attention. Its most unique feature is that it is a pixel-level unified transformer model, with no external VAE and no independent text encoder. It puts text-to-image, image editing, and multi-reference personalized generation all into a single model. Because of this feature, it has massive potential in tasks like high-resolution generation, complex layouts, text rendering, and reference generation. That wraps up our coverage of the HiDream-O1 model for today. What are you waiting for? Go ahead and try it out for yourself. Follow me to become someone who truly understands AI.